My name is Elad. I'm the latest addition to the Swarm team. I joined about 3 months ago. I've been involved in various projects in the past, from stuff in media and to real-time homeland security systems, embedded systems, and in the last couple of years also a bit of bread and butter corporate backend web systems. So I'm really excited to be here today and represent the Swarm team. And I'd like to take a moment to thank the good people of Status for inviting us and for their involvement and support for Swarm. So thank you guys. So let's get started. Basically, how many of you here have heard of Swarm? Okay, that's pretty good. How many of you tested it, managed to get through the setup stage? Okay, not so many. And how many of you are building applications on top of it? All right, fair enough. Okay, cool. So let's get started. I'd like to start with something that Victor portrayed as something very clearly as a hand-waving, but I think for those of you which are not familiar with Swarm, I wrote this really short paragraph about what it is, or what it is for me and what it means for me. So basically a rapidly evolving digital vessel that conveys information, democratizing and redefining existing schemes of information exchange and their bounded economics, and for the first time puts the digital individual as an active participant of the internet. So I think that this as a kind of an introduction, kind of 100,000 feet above the ground, is a good phrase of the impact that Swarm is about to give to the third web. So basically, what is it? It's a P2P content address storage and delivery network. And it is an integral part of the third web's vision of the Ethereum Foundation. It handles archival and retrieval of data with a bounded incentivization model, which is, of course, with Ethereum. And built to serve web applications, or dApps, with real-time messaging. But most of all, it's a silly world of acronyms, riddles, and mnemonics. So Swarm basically defines three crucial notions. We have chunks, hashes, and manifests. So chunks are our most basic data type. They're limited to 4 kilobytes, hold the arbitrary data as well as other Swarm primitives, which we will get to. And they are redundant over the network. Right now, each chunk is stored 3 times on the network, basically. And they reside, or being actually stored, in the closest proximity to the participating nodes' IDs or addresses. In Swarm, the notion of proximity is not of geographical proximity, but of basically the proximity between addresses, which we do using Xsource. And next. So basically, what are chunks? So we have 4 kilobytes chunks, which are split into 128 32-byte segments. These are being hashed with a binary Merkle tree, and then we get the binary Merkle tree hash. So each chunk has a BMT hash, and Swarm hashes, they basically represent the Swarm trees of hashes with a single content address SHA-3 hash of the content. It's basically used for a Merkle tree representation of arbitrary data, and theoretically collision-free. They facilitate proof of custody, future proofs of custody, and they, as mentioned, they share the same address space of the nodes themselves. So we said that chunks are 4 kilobytes in size. So basically, once we have basically 128 chunks, we pack them into intermediate chunks that hold up to 128 hashes, which in turn are used to get one root hash of the file. So files are retrievable using a single 32-byte hash. And they have built-in integrity protection as of such, using the Merkle tree, and support hierarchical encryption. And of course, due to the fact that random access is supported on the lowest level, so we preserve integrity protection and encryption. Next, manifests. So manifests are basically collections. They define mappings between arbitrary data and arbitrary paths to files and handle collections. They contain metadata about files, and so that browsers could actually have the correct metadata conveyed to them in order to display information correctly. And they're represented as compacted tries. Manifests, basically, they are the mechanism that provides the access to content on Swarm using URL-based addresses. And they are exposed through the BZZ URL scheme. Another thing about manifests is that you can think about them basically as a routing table or as an index or a directory tree, which basically allows for Swarm to implement websites, databases, or file system directories. So a little bit on how it looks like. So once you upload something to Swarm, using this is the CLI upload, so you basically get a hash. So this hash represents the manifest, which holds the data for this directory. This is how a manifest actually looks like. You can retrieve using the BZZ raw URL schemes. We get to that a bit later. But then you can actually see how manifest looks like. So you can see that it holds hashes, content types, and there's other metadata which is included there, but it is irrelevant for this example. This is kind of the introduction to the basic data structures and notions that we define. We kind of clear until now about this, more or less? I guess so. Okay, cool. So now to get to the meaty part of the presentation. So about a year ago, Swarm team started a big project which was called the notorious Swarm Network Rewrite Project, in which they rewrote basically all of the network layer. So after 1 year and a feature branch which was almost about 1,000 commits from Ethereum Master, on the longest day of the year we released Swarm POC3. So that was a very big achievement for the team. Released on the longest day of the year. Network layer rewritten, supports encryption now out of the box, and messaging with PSS is now merged on master, so you can toy around with it, and supports mutable resources, and has a network simulation framework, which we will get to also, and brand new documentation. So kind of really top level about this network rewrite. Maybe can I have another mic? Can I change the mic? So the connectivity layer was rewritten, Kademlia routing, discovery and routing. chunk and signing process was redesigned, and we have a more generic streaming implementation, and also resumable multi-peer downloads. So encryption, we support encryption now out of the box, using counter mode encryption, which enables us for selective disclosure of data, meaning you don't have to disclose the entire content of the data that you stored through a specific hash, but you could store a whole chunk of the whole chunk of data encrypted, but you could disclose just a part of it without revealing the encryption keys for the entire content. It will be user complete with the incorporation of access control trees, which we hope to start hacking through next month. And you could distinct encrypted content from normal uploaded content since it has a double length hash. Right now it is not deterministic, or let's say it's not deterministic and not idempotent due to the fact that we generate random encryption keys on the fly when you upload something. However, this will be addressed in the future with introduction of user-provided encryption keys. Thus, you could upload something multiple times and get the same result, basically. Yeah, the API is exposed both through the CLI and HTTP. Yeah, so this is more or less how it looks like. So you can upload a file with an encryption flag on a CLI, and you get longer hashes, and then if you try to upload the same file again, so you will get a completely different hash. And yeah, so a year ago we had also just 3 BZZ URL schemes. So we had the normal BZZ, which is your go-to, basically, scheme when you want to interact with content, uploading and downloading. And then we had BZZ raw, which is actually the scheme which is being used under the hood by all of the other schemes, and BZZ immutable. So today, we have much more of these Bs. So we have BZZ resource, which is basically how you access mutable resources and interact with them. BZZ hash, which is used just in order to do ENS resolutions through Swarm. BZZ list, which allows you to list contents of manifests without actually downloading the content. And yeah, BZZ raw and immutable were just renamed. So BZZ hash is how you use it, basically. So you can just curl an ENS name and get the hash for which it points to. This is about BZZ raw. So if you get a specific, this is the same hash that we actually queried here. And then when you BZZ raw this specific manifest address, you get the actual manifest. But if you use the normal BZZ scheme, so you basically, you will get the default content which this manifest is supposed to serve, which is the Swarm website. And so, yeah, a couple of more examples here. Yeah, you could get a hash also of a specific path that you already know, but you don't know where it points to in the manifest, so you could get the hash using BZZ hash also, as another use case. So, PSS. PSS is bzz and sh from Whisper together, so we get bzz. So it's basically a node-to-node messaging service over Swarm. Important to mention is that there's no mailboxing or persistence in any way. at this point. Although we're trying to kind of take a crack on how to do mailboxing, but it's not that straightforward. It is encapsulated using Whisper, hence and it is exposed right now only through JSON RPC. So you have to use basically a flag that we introduced, which is --WS, which introduces a WebSocket server that you can connect to and use JSON RPC calls. So, yeah, basically, another interesting point is that we have a Diffie-Hellman handshakes provided when you use our handshake modules. And basically, PSS offers a sliding scale of anonymity in trade of performance. So you could basically send a message to someone using PSS without revealing the address of the receiver. And so in PSS, the receiver is the node that can decrypt a message. So basically, you can associate a topic on PSS with an encryption key, and you can send a message over the network without revealing the address of the, you could actually do a broadcast, and you could address a message to a certain node without revealing the identity, basically. So you have a sliding scale of efficiency as a trade-off for anonymity. Yeah, so basically you could reveal the exact address, or you could actually broadcast it to a certain scope of addresses without revealing all of them. And for sure, messages get forwarded only once, so basically the network doesn't get flooded with it. So another interesting, this graphics is from Lewis's presentation from PSS and MIU, he wrote them basically. And what are mutable resources? When you want to point a hash from ENS to content on Swarm, you basically set the hash on the ENS contract. And when you want to update content, you have to change that hash to the latest version of your content's hash. And that these updates are expensive and slow. And you're left at the mercy of miners, basically, to put the updates on the blockchain. So basically, what we have created is a system of deterministically issuing updates to resources on Swarm through a fixed entry point. So you have a hash of a certain mutable resource chunk, which Swarm then follows and basically brings you to the latest update. Right now, it's undergoing pretty extreme refactorings and redesign, but it's almost merged actually. Yeah, and the big change which was introduced now is that resource updates signatures are being done by clients, and in the past, basically the nodes had to verify the ownership of the ENS name that you're updating with ENS. But now, basically, you could create an arbitrary mutable resource which has basically no connection to an ENS name, and just point the ENS record to that hash, and yeah, and you sign the updates. There's no multisig support, but you sign the updates, and and the network can verify that these updates are truly yours because of signatures which are included in the initial mutable resource chunk. Yeah. So another nice little feature is the network simulation framework. So basically, we had to write a network simulation framework in order to actually simulate how the network behaves and to actually simulate very complex behavior of nodes joining and leaving a network. And so this was finally merged. This was used during this Swarm network rewrite, but wasn't merged on master. But you could, there's a small eye candy actually that visualizes how this thing works. Let's see if this works. One second. So it's just a recording, but basically you can see a simulation running where nodes enter and leave a network, and there's this is just the overlay of this. Like you can't really. It's just you just visualize the topology here, but so underneath all of this, there was built this incredible simulation framework, which they had to really grind it to work properly and be able to actually simulate networks which drain resources pretty quickly to run on a single machine. Yeah, so this is another big milestone for the team. And yeah, and we have new documentation which you can access, and hopefully it will get you through the setup stage much more easily and faster, I hope, with better examples and a lot of resources that you can actually read and understand Swarm much better. Takes time to actually onboard to such a huge and complex project. Yeah, a bit of what we're doing these days. So since we changed a lot of these, a lot of the BCC schemes, so we have to reintegrate into Mist. So as I said before, we're going to try to get access control trees implemented in the near future. There's a few evangelist light client developers that are popping up and trying to help us to implement actual light clients for mobile. Yeah, erasure coding is coming at some point also. But I've been given the directive to not give any specific dates or time that we can oblige to. I hope you can understand. Yeah, so yeah, come and join the fun. We have open Gitter room that you can come and engage with us. Source code, you know where it is probably. This link is for the Swarm gateways, and we're hiring if anyone wants to join the team. So thank you, and if you have any questions.
Thank you so much, Guido. It's really exciting to see Swarm coming along. So the mutable resources stuff is what interests me most, and it seems like you guys have made some really, really good progress there. Simple question around the multi-sig, because obviously, like, if I lose my keys, then I can't update my sites or whatever content I'm serving anymore. What specifically is blocking you there, and do you have any sense of how easy it would be to fix?
Well, I think they just didn't get to that yet. Right now, it's more about finalizing the implementation, because we had a dependency on ENS basically to issue updates on the network. So basically, now we actually decoupled from ENS in that manner for the verification, and also for the verification that nodes do when they pass along chunks. So to see that these chunks are not basically updates issued by somebody that just wants to hijack your content. Yeah, that was pretty much redesigned. Also, we don't use block heights for issuing updates, but rather now just Unix epoch times instead. And yeah, but the multi-sig updates, I have to check with Lewis about this, because I can't give you an informed answer about this, but I know that they have it in view, so this is definitely something we are talking about, so yeah.